All right, guys, I wanted to make a quick video of a 7.41. So this actually uses all the skills that you should technically already have, though I know that they may be hard to remember. All right, so some of the stuff I'm about to write may be like you may not have enough space. So if you need to use an extra sheet of paper, feel free. So if you read the first problem, right, the key word on here is a new linear road. Linear as in a line, all right? And it says that it plans to be constructed perpendicular to an existing one. On a representative graph, the survey determines that the existing linear road, again, passes through these 2 points, right? And the roads must intersect at 4, 7. So if I want to determine the slope of the new road, remember, the new road has to be, both of those roads have to be perpendicular, right? So what I can do here is I can find the slope between 2 points, right, to figure out the slope. Well, so remember the slope formula is m is equal to y sub 2 is minus y sub 1 all over x sub 2 is minus x sub 1. All right, so I can kind of do that. Remember, it doesn't really matter which one you call x2, y2 or x1, y1. All right, all that matters is that you can, let me look at my notes here real fast. Okay. So in my case, what I'm going to do here is I'm just going to call 15 and 2 x2, y2, right? And then my x1, y1 is going to be 4 and 7. When I do that, I ended up with a 8 over negative 2, which gives me a slope of negative 4. Now, remember that this slope, the road that you want on here is perpendicular to those two, to that line, all right? So therefore, if the slope between the 2 points is negative 4, the road that would have a perpendicular slope would have a slope that would be the negative reciprocal of it, which in this case, that would be positive 1/4. Right, so don't forget that I changed the slope only because the slope was perpendicular. So that's the answer to A. Right, on part B, when it says to determine the equation of the new road, notice that it says that it must intersect at this point, right, 0.47. So therefore, if you remember, I have a formula that's called the point slope formula, where the only thing you need to plug in is the slope and the point, as the name implies. So y stays a y. y1 you can pick, in this case, as it wants me to intersect through 0.47, I'm going to pick that point, okay? So that point right here, 47, y is 7, or y1 is 7, slope is 1/4, and then x1 would be 4. All right, so now, if I distribute that 1/4, let me wait for this to finish saving. If I distribute the 1/4, I would end up with a 1/4 x minus 1. Remember, I'm distributing the 1/4 to that one, okay? And then if I add 7 to both sides, I would end up with a 1/4 x plus 6. All right, so that's the answer to part B. All right, so now let's go to the quadratic model example here. So notice that in this case, they give us a formula, luckily, all right? It's already quadratic. Remember, we're saying that this is quadratic only because the highest degree or the highest power is 2, which is going to make this a quadratic. All right, let's see. A 12-volt battery has a resistance of 4 ohms. Due to this fact, the available power to start the car is modeled by the function, where the power P is measured in watts. All right, this is going to be nice information to have. When and if this comes back, my bad. This apparently has kicked me out again. All right, so no big loss here. P is measured in power P is measured in watts, and the electric current is measured in amps. Okay. Now the very first question is very simple. It just asks what are the zeros of the function. So don't forget, the zeros of the function, all right, can be found by setting this equation equal to 0. So I'm going to rewrite it here. I'm actually going to write it a little bit backwards. I don't really like the x squared power to be second. So there's several ways you can do this. You could use Desmos, for example, a calculator, which on this homework we are allowed to use it to a certain extent. So we can use that and see where this graph crosses the x-axis. Okay, another way to do this is by factoring. Another way to do that is a quadratic formula. So I'm going to pick one way. Notice that this one right here has a common factor, and this might be hard for you to tell, right? These two, negative 0.04 and 16i, have a common factor of negative 0.04i. So that's the common factor, right? Now, how did I know that? Yeah, I had to use the calculator on that part. When I factor that out, I end up with I minus 400. All right? So that means that I can set each factor equal to 0. I'm going to write that on the margin here. So if I set negative 0.04i equal to 0, then I will be 0. And then now, if I set I minus 400 is equal to 0, that means that I is equal to 400. All right, so my two roots, which remember, that's as many zeros as I have. This is a degree 2 function, so therefore, by the funnel theorem of algebra, I would only have two roots, okay? So my answer here would be 0, 0, and 400. All right. Now, in the very next question, this is actually a simple question, especially if you kind of figured out what I said here, that P is measured in watts and current I is measured in amps. What is the current? All right, so remember, current is, in this case, I believe. So we don't know what I is to create 1,599 watts, which is P. Okay? So what that means is that we already have the letter P. Remember, we're still using this formula they're going to give us, all right? So we want to know. Okay, so I'm going to rewrite this again, that formula. I'm going to write it, let me write it over here. So I have negative 0.04i squared plus 16i, and that's equal to 1599, right? Because remember, that was power. So what I'm solving for here is I, okay? Now, anytime you're solving a quadratic function, the first thing you must do is set it equal to 0, right? And by that, I mean, I am going to subtract 1,599 from both sides. And when I subtract that from both sides, I get that equal to 0. So now this is equal to 0. Of course, I could try to factor, and it turns out there is a factor. I didn't know that. But the only other way to do it, all right, especially if all you have is a 4-function calculator, is just to do the quadratic formula, all right? So what I'm going to do here is the quadratic formula. So remember, where this right here would be A, this is B. I'm talking about the quadratic formula again. And this is C. Remember, the quadratic formula, which I'll write up here, but I'm probably going to erase it, is negative B plus or minus B squared minus 4AC all over 2A. All right, so this is what I'm getting all those numbers that I'm about to write. So this is going to be negative 16. All right, so I, in this case, instead of x, I is equal to negative 16 plus or minus saving. It's going to be equal to 16 squared minus 4a, in my case, is negative 0.04. C, let me really zoom in. C would be 1599 all over 2a. 2 times negative 0.04. All right, so if I run that through the calculator, remember I have to run it one time with a plus, okay, and another time with a minus. So I have to do this equation twice. It turns out that what I get is, I get this. I guess I'll break it down into a couple of steps here. You get plus or minus 0.4. That's actually what happens when you take the square root of all that stuff. Divided by 0.08. Right? And one answer that you're going to get is 205 amps. Another answer would be 195 amps, right? So this actually happens twice. So remember, I know this is a equation that's talking about power and current, but at the end of the day, it's a quadratic, and in this case, we happen to have two answers, right? And both of the answers seem to be viable. All right, now, line of symmetry. You may not remember this formula, but the line of symmetry can be found by the axis of symmetry is x is equal to negative b over 2a. Remember, I'm still referring back to this one right here, okay? So in my case, negative b, let's see, negative b, is this part C? Yes. Did I write it? No, I did not write it. Oh, yes, I did. Okay. All right, so negative b would be negative 16. By the way, this is the answer for B. And I'm about to write the answer for C. All right, so this right here would be equal to 200. All right, so that's where the axis of symmetry is located. And don't forget what that means, all right? And going back to this, and we kind of probably figure that out, all right? Just to kind of connect it all for you. If you remember, and we really were talking about this formula. That was my bad. All right, though the answer does not change. If I tell you that the zeros are 0 and 400, remember, this right here, you have a negative, and this is an even degree and negative function, which means I have a parabola. In this case, it's a parabola because it's degree 2 that looks like this. Okay, and this was 0 and this was 400. Remember, that was from part A. Well, if I ask you for the axis of symmetry, the axis of symmetry happens to be right between those two numbers, which is x is equal to 200, which is what I got here. All right, so just kind of putting it all together for you. Okay, let's move on to the cubic model. Now, the cubic model, I'll be honest, I had to look this up because it's going to ask me to do this with a matrix, right? So, again, they give you a table, all right? And just to make sure that we're clear, this is a type of diving board, and why is the deflection of the board in thousandths of an inch, right? Because when I read this, I was like, so you mean to tell me the deflection is at 972 inches? It wasn't. It's just 0.972 if you take that as, thousandths of an inch. So anyways, so this would have been 0.972, but I regress. So here's the problem, right? This is a cubic. It tells me that it's a cubic, okay? And x is the distance, so x is the distance from the diving board, calling this 0, for example. And then the distance from the diving board kind of tells you how far down the diving board is going to like dip in, if you will. So regardless of that, the hard part about this one, right, on part A is it's going to ask us to use a coefficient matrix, okay? So that's the part that I had to look up because I really couldn't remember that. So I'll tell you what page this is on in case you're interested. This is page 60 on unit 4. So this is where I'm getting this. And I know you probably don't remember the inverse matrix, but maybe this will be a nice refresher. All right, so they want us to use that table. Right, and on that table, what they told us was that I needed to write the coefficients like 0 cubed. I'm getting that from here, right? Now I'm only writing 0 cubed because they want a cube function. 0 squared, 0 to the first, and then 1. Remember, the last number is always 1. And I'm going to go to the next number, which is 1. So we have 1 cubed, 1 squared, 1 to the first, 1. And I'm going to go to the next number, which is 2. 2, that looks like a 13 here. Let me make sure we're on the same page here. This is 1 to the third power, not 13. So 2 to the third, 2 to the second, 2 to the first, and 1. And then finally, 3 cubed, 3 squared, 3 to the first, and 1. And we're going to take the inverse matrix of that, and then we're going to multiply by the coefficients, by the y values attached to that. So this will be 0, 116, 448. And I understand you may need practice with that, so make sure you grab a Inspire calculator if you need it to kind of follow along. All right, so now, in this part right here, okay, notice that the letters that I'm going to get an A, B, C, and D. So I should get 4 numbers from this. All right, so when I run the numbers through the calculator, it actually gives me this. It gives me -4, 120, and it gives me a 0, 0. So what that means, is that this answer would be y is equal to -4x cubed plus 120x squared plus x plus 0x plus 0. So of course this last two parts we don't have to write. We can just write what we have there. Okay, so now we can go ahead and go on and basically answer the rest of this with the formula we just got. So the first question is what's the multiplicity of 0? So what that means is if I were to solve for x here, right, and I can do it over here on the left side of the margin. If I were to set this equation that I got, the one that I just showed you, -4x cubed plus 120x squared, if I set that equal to 0, and I'm setting that equal to 0 because he wants to know one of the zeros of the functions, right? So this is what's going to happen. Look at this one's not bad. It's not bad at all. We can actually find the greatest common factor here, which in this case would be -4x squared. And that would leave me with x minus 30. And I would set each factor equal to 0. This factor is equal to 0. This factor is equal to 0. Now this right here, if I divide both sides by -4, I still get 0. Right, this one, well, that one's easier. That's 30. Now this is multiplicity 1, so this is not the one they're talking about because they're saying that this has a multiplicity. It wants to know what the multiplicity of the 0 as the 0 of the function. So basically, they want to know the multiplicity of this side. So the right side, though, is the right answer, is not what they're asking here. If I take the square root, and this is a part that's a little bit difficult. If you have an x squared is equal to 0, the answer is obviously going to be 0, but this is actually a multiplicity 2. So again, anytime you have x squared is equal to 0, the multiplicity is going to be 2. If you had a x cubed is equal to 0, well, then you would have a multiplicity of 3. All right, so this is what they're looking for in part A. All right, now the next part is relatively straightforward. It's asking what is the deflection of this board at the tip if it is 8 foot long. Okay, so if the board is 8 foot long, all right, notice that feet, horizontal distance is x, right? So I would plug in, I just want to know what happens when I plug in an 8 into this function right here, right? So I want to know what happens when I plug in an 8. So of course you can do this with a calculator if you wanted to. You could use this with, you could use synthetic division using the remainder theorem, if you remember that, right? But if you plug it all in, that's gonna give you 5,632. Now remember, these are 1,000ths of an inch, right? So don't forget that, because otherwise that number seems really big for what we're doing. All right, finally, on this part, on part D, it says some functions used to model data only work in limited intervals in the domain. Explore the graph for this particular function, identify the interval where the model breaks down as reasonable model, blah, blah, blah. Okay, so here's things you should know, okay? You should know what this looks like on a graph, at least in general, right? Remember, we said that this is at degree 3 and negative, so we know that it looks something like this, right? Remember, left hand up, right hand down. And then we also know that the zeros of the function were 0 with a multiplicity of 2, and x is equal to 30 with a multiplicity of 1. All right, so I'm going to answer that question for you. Now remember, I know that's what it looks like. I'm supposed to go through those two points on the graph, okay? So if I go through those 2 points, let's see, that would look something like 0, yep, 0 is a double or a multiplicity of 2, so I'm going to bounce off that x-axis, come back up, and then go through 30, okay? Now don't forget that the y-axis is the deflection of the diving board, and x is the distance from the beginning of the diving board to the edge, if you will. So it follows that I cannot have negative deflection, so I can't go below that, and also I cannot have a negative distance from the diving board. So although the function looks like this, the only viable domain in this case would be from 0 to 30. Right, again, that's because x, the distance in feet from the diving board, cannot be negative, and the deflection of the fiberglass diving board also cannot be negative. So this would be the answer to the last part. All right, last but not least, this Quartic model. Luckily for us, it gave us the actual equation, which is really nice. Now, it's asking us to use the graphing software to graph and find the real zeros of the function. Now, I will tell you can use an Inspire. However, especially if you're at home, use Desmos, right? So if you just go to Google and Google Desmos graphing calculator particularly, it could actually graph it for you. So notice it right here, I've already graphed it. Now, it wants to know the zeros of the function. Now, notice that one of the zeros is obviously 0, right? And hopefully you can tell that that's a triple root, right? And then the other root, it's right here. And if you just put, and I know you cannot see my hand, but if you just tap where it crosses the x-axis and hold, or if you just keep your finger there, notice that it gives you the actual root, which in this case is 27.897. So you have 2 answers. One of them is the one I just showed you, and the other one is 0, 0. That one I can't quite get it to show up. Oh, there it is. All right, so that's it for that. Let's see, let's write that again. So we can use the calculator on that part. In this case, t, so t is equal to 0, and t is equal to 27.897. Now it says, what must be true if there were 2 zeros? Now remember, this is something that I covered previously, but if the degree of the function is 4, all right, and I have 2 real solutions. Now, how do I know they're real solutions? Well, because you could actually see them go through the x-axis, all right? So what this means is that the 2 other zeros is that they must be imaginary. Because remember, if this is a degree 4 function, you should have 4 roots. And in this case, I have 2 real roots, so that must mean that I have two imaginary roots on top of those, okay? Now, finally, it says explain the end behavior. So that part should hopefully make a lot of sense to you. I mean, obviously you can look at the graph, but notice this is degree 4, right? And it's negative. So therefore, the end behavior is both arms down. Now, just to remind you, if we write this mathematically, though, we would say as t, which in this case is x, as t goes to infinity, then c of t, which is the y value, if you will, goes to negative infinity. All right, and as t goes to negative infinity, c of t goes to negative infinity also. Okay, well, that's it for that. I know we went through this really fast, but let me know if you have any questions. I'm sure you will, so we'll definitely have some time to work on these, all right? Until next time.